Okay, thank you. I'm Santi. I'm from Argentina, as they said. I'm really happy to be here, and also I came alone, so I'm ready to make a deal with you. I could trade some pictures with beer, so if you reach me and give me some pictures, I can buy you a beer. I'm an incident responder. I work mostly in cloud security. I used to be a federal police back at home, but a couple of years ago, I moved to the cloud space, and then I started to lead the incident response team, specifically in the cloud. So what we are going to see today is a little bit of how to use anti-forensic techniques to test our detection engineering and our log collection strategies, and how are we shipping information to our SIEM to better understand what are the capabilities that the different, specifically AWS as a cloud providers, offer us to collect logs, to ship them to the SIEM, and what are specifically the delays, and what are the pain points that we can exploit as attackers to make the blue team life a little bit harder, and what we as a blue teamers can do to better enforce our strategies besides what is like the minimal default things that we apply when implementing a detection strategy. I always like to start with the shared responsibility model because it's super important for us to understand, if we are working with the cloud, that there are things that are going to be outside our control. For example, if we are working with AWS, there are serverless stuff that we cannot implement an EDR on. So we need to relegate the hardening of that component to the cloud provider. And most of the time, they do it well, but not always, especially when we leave the main cloud providers like AWS. And nowadays, we need to stop thinking that the cloud is only the cloud provider. So we are also using SaaS SIEM solutions that are also another shared responsibility model. So when we are thinking a detection strategy, we also need to understand what are the security boundaries that are out of our control when implementing that strategy. One important thing is, for example, how much time does the SIEM take to get our logs? That's why I think this is the most important slide in the whole presentation. This represents typical architecture on how to ship logs and events to a SIEM from AWS with every different path and what are the delays in each one of those paths. As you can see, if you implement stuff in the traditional way, you can get, for example, getting logs from CloudTrail that is going to get all the API calls working in AWS to an S3 bucket, and then we ship the S3 bucket logs to a SIEM. Maybe we can get up to 25 minutes of delay in that kind of integration. But then we can implement the same integration using CloudWatch instead of an S3 bucket, and that would make everything faster. We are going to get 6 minutes of delay whenever we are shipping that information. So that can make a difference when we are trying to generate alerts and we are taking that time to respond as a blue teamers. And also, if we understand what is the SIEM integration as a red teamer, I can get how much time do I get to tamper that implementation, to compromise the supply chain, and to stop that information to arrive to the SIEM. The idea of this presentation is for us to understand different attack paths to each of those different components. We are going to work a lot with the supply chain here. Another important thing that we need to understand regarding AWS is like there are a lot of logs that can be enabled. Most companies don't make this happen. Most companies don't have everything enabled because we tend to believe that the cloud provider is going to take care of that, but that's why it's important the shared responsibility model. Most of those logs require us to enable them. Most SIEMs doesn't handle instant normalization and parsing, so there is another extra burden from the defensive team to get those logs to the SIEM, to ship them, to normalize, to parse them, and to generate alerts on those. So we need to be able to understand if the cloud provider, if the defensive team is handling them, because those are the main points that we need to attack for us to be able to keep going within the attack without being detected. So antiforensics, what's the important thing about antiforensics is like we need to obstruct or make the life of the defensive team harder, right? In this talk, we are going to destroy evidence, but the idea is that on the way that AWS is built, if we destroy the important log sources without prepare ourselves before, alerts will trigger. So we need to first obstruct the way that the defensive team is going to get those alerts. So we need to work in a progressive way for us to trust that what we are doing is not going to be detected. So there is previous research against this topic. There are a lot of talks presented in Black Hat and DEFCON regarding how use non-enumerated APIs, how use testing APIs from AWS. Most of those talks refers to vulnerabilities that have been patched. My presentation includes misconfigurations that are not going to be patched. So the difference with those research is that this thing, what I'm going to present, it's not going to be fixed by AWS. It depends on how the client implements their defense strategy, and most of the clients that I have worked on, they had these issues, and we were able to exploit them, so it's based in real cases scenarios. So we're going to handle 3 practical approaches. I'm going to explain briefly the theory, and we are going to jump quickly to a demo in which we are going to try to exploit these 3 stuff. First of all, I'm going to explain you how we can tamper Guardduty. Guardduty is a threat detection tool that AWS offers us that we can enable it with 1 click, and it's going to be like monitoring everything. It's easy to bypass, but every year it's improving, and we need to understand how we can manage it to make our life easier. So we are going to talk about whitelisting and suppression rules. Then we are going to understand how the log supply chain works. So how CloudTrail ships logs to S3 and how we can tamper that to stop it from happening. And lastly, we're going to attack a detection event-driven supply chain so we can complete the first diagram that I show you. So let's start with Guardduty. This is the part of the diagram that we're going to review now. Basically, this is how a Guardduty dashboard looks like. We can get a lot of detections from different components. I have 1 integration set in Discord, like this. I'm receiving notifications from everything I'm doing. This is like brand new for you to get an idea. I have like 2 Discord channels receiving notifications of what we are doing, and this is what we are going to disable. I have an alerts channel and a control channel, so whenever we execute the attack, the idea is for us to look for 2 things. First of all, if we are getting the delays, and second, if we are able to tamper that integration to stop the alarm from happening. In order to do this, we can create suppression rules. The suppression rule allows us to automatically archive an event based on a parameter. For example, we can archive it based on an IP address. So if I know that my VPS events are coming from an IP address, I can create the suppression rule, and the event is going to be automatically archived. This is how you can create a suppression rule. It's a simple trick, but most SIEMs are not looking for whenever the detection alarms from Guardduty stop from coming. It's like if you are ingesting logs and suddenly you stop getting the logs, you're going to get an alert. But whenever you're expecting for an event-driven strategy to be implemented, you're not going to trigger an alarm if you don't get an alert from one whole day because it's expected behavior. The alarm should be like an exception. So and also SIEM solutions are not checking if you have suppression rules, but because also the suppression rules are part of the default behavior of the operation teams to handle false positive. So it's hard for the defensive team to understand which suppression rule is from their team and which suppression rule comes from the attacker. The same happened with whitelisting. Guardduty allows us to upload IPs whitelistings for us to stop analyzing those IPs. So again, if I know that I'm going to execute an attack from a VPS, I can insert that VPS in the whitelisting, and those events are going to be automatically archived. Now let's go with CloudTrail. CloudTrail, as I told you, is the AWS services that allows us to collect every API call that's happening in AWS. Everything in AWS is an API call. So if I create a server, it's going to get an API call. If I create a suppression rule, that's going to generate another API call. So in order for us to create a suppression rule in a safety way, we need to stop first CloudTrail to happening. So we're going to focus on this integration. As you can see, the default integration with CloudTrail in order to ship those logs to a SIEM is from AWS CloudTrail to an S3 bucket, and from the S3 bucket triggering a Lambda function that will push that information to the SIEM. There is another type of integration that is going to require the SIEM to pull that data, but then you add to those delays the time that the SIEM takes to pull that data. For example, in QRadar, it can be up to 10 minutes. So for the 25 minutes that I told you before, you need to add another 10 minutes. That it's like 30 minutes for you to have fun. This is like the extra layer of the architecture. In AWS, you have user policies that will allow me to do stuff that are the permissions that I require to change whatever I'm going to change to tamper the S3 bucket. And also we have resource policies. The resource policies act first, and they allow, it's the resource entity that allow every other entity to work with that resource. So if I have a resource that has a resource policy that blocks me to do anything, no matter if I'm full admin, I'm not going to be able to execute any action against that bucket, right? So we are going to work with that policy. The idea is for us to understand how they work to block whatever is going to be stored in the bucket, in this case, logs. This is how the resource policy looks like. As you can see, there is a principal. The principal entity says that CloudTrail is allowed to put objects in the S3 bucket. What we are going to do is change that policy to say that now Guardduty is allowed to put objects in that S3 bucket. That will block the CloudTrail possibility to store logs in the bucket, and also when the incident response team is analyzing, it's going to read Guardduty, and as it's a common word, they're going to think that's not as bad, or they are going to pass it. The issue with this kind of implementation, besides it makes CloudTrail stop logging, it's going to be noticeable for the defender team because CloudTrail will pop an alert that's going to say, hey, the bucket is not accessible. And also, if the SIEM has an alarm when the logs are not coming, it's going to trigger. So it works, but we can make it better. Making it prod ready requires us to understand a little bit more about how AWS works. We can implement a regional approach. In AWS, we can apply resources in different regions. So if the company is working in US East 1, we can create a policy denying the action of put objects in the bucket in Brazil, for example. So then I can move and work in Brazil, and what's going to happen is that the logs in US East 1 are going to be created, but the logs in Brazil are not. So the SIEM is going to keep receiving logs from the main region, but they are not going to receive logs from the region that I'm working on. And also, CloudTrail is not going to tell that the bucket is not accessible anymore because it's going to be able to ship logs in USS1. With this, what we are going to do in the demo, we are going to remove the deny policy for you to understand that whenever I remove the policy, the logs are going to be shipped again. Lastly, security detection. Security detection, we are going to work with this integration. We have Guardduty enabled. We are going to ship the Guardduty alert through CloudWatch to a Lambda function that's going to trigger the Discord notification. That's the integration I showed you before. So what we are going to tamper here is what's called the event bridge rule. The event bridge rule is something that is analyzing a bus that it's shipping all the API calls that are passing through before arriving to CloudTrail. They are going to be analyzed with this rule. And this rule is going to say, OK, if you find a Guardduty finding, send that to a Lambda function. This is blazing fast. It takes like 1 minute to trigger. And it's the desired implementation for real-time detection and response. The thing with this type of implementations is that the bus can generate a lot of data. So if we integrate our log collection from this bus, we can spend a lot of money. So that's why it's not implemented and the other integrations are chosen. So the main idea, what we are going to do is we are going to tamper this event pattern. So whenever the rule triggers the second rule, we are going to bypass our source IP from that trigger. So whenever the Lambda is going to receive an event, it's going to filter our source IP, so the origin, it's not going to be in the Lambda function. But whenever they receive information from another event that doesn't come from our source IP, it's going to trigger the Lambda function and the notification. Why is this important? Because we can work with any field of the Guardduty event that is a JSON file. So we can work with user agent, we can work with specific detection rules, we can filter whatever we want if we are able to modify the CloudWatch rule. And also, the CloudWatch rule is part of the normal implementation of development lifecycle. So it's common that operation teams need to modify CloudWatch rule because it's also the bus that is used to manipulate infrastructure alarms. So it's common for us to get access to permissions that are able to modify this kind of issues, of policies. So OK, that's enough of theory. Let's go with the demo. There is a special challenge with this demo is that I have to manage the 3 delays at the same time. The delays of CloudTrail, the delays of Guardduty, and the delays of Discord and the notification. And it's a live demo, so let's pray to the demo god that it works. Here I have CloudTrail. As you can see here, we are in the Brazil region. We are in the year 2025, and we haven't had logs from September yet. But if I go here to see what's going on in another region, like USS1, we are going to see that in 2025, we do have logs for September. That's why. Why is that? Because I have in the policy, as I show you, this deny parameter. As you can see here, I'm denying the Brazil region and also the digest. Why I'm denying the digest? Because whenever I do this, the digest allows the incident responder to validate if the log was tampered. But the digest is also stored in the same bucket. So if I deny the CloudTrail access to generate the digest, the last digest is going to be the valid one, and the check is going to be true. I can show you that afterwards, but it takes some time. What we are going to do with this first is to modify the policy so we can have So we can remove the deny. What I want you to get from this is that when we finish the demo, this can take up to 15 minutes of delay, so that's why I'm making this first. But the idea is that when we finish this demo, we should see logs being generated in here, right? This is the first time. Remember that. We need to see September being generated here after we remove the tampering. Then we have this Discord notification Lambda, and this is the Discord notifier that we're going to tamper, and this is the Discord control. The Discord control is the one that we're going to see, to use, to validate that the tampering in the event breach rule work as we intended, right? So we have in here the Discord notification that I'm going to tamper. As you can see here, we have the event pattern that I showed you before that's going to trigger when we had a Guardduty event, right? So we're going to edit it. I'm going to get my machete, and I'm going to get the policy that I show you that is going to bypass my IP. For this example, what I'm using is the source IP of the generated event finding that I'm going to also create in the console for testing. So what we're going to see here is when I generate a sample finding, the sample finding is not going to be triggered, but if a finding for me to use the IP of the Wi-Fi here, I haven't whitelisted the Wi-Fi here. That event should arrive even though, right? So we are going to do some noise in here for us to understand whenever something new comes. And we are going to use this command. This command allows me to create a sample finding in Guardduty. I need to pass it the Guardduty detector ID, and I'm going to generate a malicious IP caller, right? This API call is also useful for us to generate noise. We can generate sample findings, and if the detection engineering team hasn't skipped this from being shipped to the SIEM, the alert is going to trigger even though. So we can also use these API calls to generate noise in different hours and to hide our actions if we needed to. So now we need to fight with the delays, and we need to understand if the event happened as we wanted. So the first thing we're going to see is let's check in Guardduty if we have a new finding based on the sample finding I generated. And it's this one. As you can see, the sample has been generated successfully in Guardduty. And this is going to trigger the event rules that I told you. And we have the tampered event rule, and also we have the non-tampered event rule. So in this notification event rule, we should be able to see a trigger in the monitoring part if we go like in the next 15 minutes or something like that. This is important for us to understand the time it takes from it to arrive to Guardduty and then to arrive to Discord, right? So we don't have the notification in here yet. We have the tampered one that we can review the same stuff. We can go and see for the last 15 minutes. We also don't have anything. We have an alarm. Yeah, we have the Discord alarm from not in the one that I tamper. We have the alarm in the control Discord channel. And if we go to the rule and we refresh, we should be here a point. Well, it doesn't refresh that fast. But if I go to the Discord notification Lambda and I go and try to see the monitoring, I should see here the trigger of the Lambda, and we are not going to see this in here, right? So changing that policy, we were able to generate that, to stop Discord to receive the notification. Also, we are not getting a Guardduty alert from changing that event. if Guardduty would be detecting and monitoring the event breach, we should have another notification in here, and that doesn't happen. So that's why we need to be like extra concerned regarding the event breach, and we need to check and generate our own detection use cases to monitor for event breach modification, especially the ones that are affecting our detection strategy supply chain. Lastly, we modify this the resource policy, and we should start seeing logs in here. And now we are seeing the logs from September. So the policy was preventing CloudTrail from receiving API calls and logs, so the SIEM was not receiving those logs. And when I removed that deny statement, now they are receiving that. And as you can see, the logs that were generated before I removed the policy are not there. But that happens, the same happened with the digest. So if I remove that statement and the incident response team runs the digest, that digest is not going to be there, so that is going to be validated. They are not going to understand that the log was not was tampered because there was no digest before. So it's also important to understand how the incident responders work for us to get a better knowledge on what are they going to check with the, and what mechanism do they have to test that the logs are working as intended, right? Lastly, I remember you again, this slide is super important for us to understand the delays that we have, because the delays and correct access management in the cloud are the main weapons that we have to stop having persistence in our infrastructure. And getting less risk privilege is super hard, and most companies try to make a detection first strategy, and if you are not considering these delays, you're going to get in a real mess. So yeah, I think I'm just in time. That would be it. I don't know if you have any questions. Okay, perfect.
If you want to ask Santi questions, put your hand up, or where are you going to be after this talk?
I'm going to be here the 3 days. So
whole 3 days, so you can just
and if you have pictures, I can buy you beers. That's important too.
But do we have any questions in the room? Stunned silence. Well, I think you've beaten them all into submission.
Well, thank you.
Gracias.
No, thank you. I'm glad to be here.
All right, big round of applause, please, to Santi.